before we start the discussion round, I'm happy to introduce the next speaker. Sven, maybe you can share your screen again. So the next speaker I just mentioned is a founder from a company. He was in a company or a project before, which a lot of people know here. Is from the Copenhagen suborbitals. So Eivind Liland is the founder and CEO of Orbital Machines. Are you there? Can you unmute yourself? And
Can you hear me?
Yeah, perfect. Yeah.
Yes.
I'm really looking forward to your presentation, and also where all the things come together. There was a Friday a visiting spot at the Motion Lab in Berlin. We visited it for the new space lab. And then there was Eivind Liland, a founder of a space startup, which was really surprising because you don't go into makerspace and find startup founders in the space industry. So I would like you now to share your screen, and I'm really excited to see your presentation, which was also very spontaneously. So really, thank you for that.
Yeah, what I can say is definitely that I'm curious for the office of Yuri when I've seen it, but that's just as a side note. And now I'm excited for the presentation from Orbital Machines.
Can you see my screen now?
Yes, we do.
Yep. Okay. Yep. So I'm Eivind Liland. I'm the CEO and founder of Orbital Machines, and Orbital Machines is a Norwegian company. We are developing electric turbopumps for launch vehicles. And what are electric turbopumps? Well, when you are launching a rocket into space, as you know, the rocket is driven by a rocket engine, and this engine is burning for maybe 2 minutes. And basically, the whole rocket is just full of propellant, and all of that propellant has to be pumped into the rocket engine during just those few minutes. So you need a very powerful pump. And traditionally, these pumps have been driven by a gas turbine. And now battery technology and electric motor technology has had a lot of improvements over the last decades. And it's now possible to drive these pumps electrically and still be light enough to be able to launch a rocket to orbit. And that has a few benefits. And why this right now? Well, as we've been talking about already, the market is kind of moving very, very fast right now. And there's a huge number of satellites that are being launched and are supposed to be launched over the next decades. And that's created a market for launch vehicles, and especially for small launch vehicles. And there's now a large number of these small launch vehicles in development. Many of them by startups with tight schedules. They want to get to market quickly. They're limited in funds as well. And the turbopump is actually a major pain point in the development of a launch vehicle. It's known to be risky and expensive and to run over budget and schedule. It's also sometimes the cause of launch failures, which is, of course, something everyone wants to avoid. These pumps are kind of difficult to standardize traditionally. The way these pumps have been traditionally developed, they are developed kind of from scratch for each engine, and that's because these gas turbine-driven pumps, they kind of integrate closely with the engines in several ways. And the solution, the way we see it, is to standardize this electric turbopump technology. And by standardization, we mean it's not exactly the same pump being delivered to each engine, but it's the same design, and it's dimensioned individually for each engine, for each customer, so that it delivers the correct pressure and the correct flow rate. And then each pump is still going through the same steps of production and verification. And that way we can bring down costs and reduce risks and reduce the time to market for our customers. Electric turbo pumps are also easier to control, and they are inherently safer because there's no hot gas running parallel to the fuel and the oxidizer. And this goes well with the kind of the selling point for these small launch vehicle companies, because they want to be able to launch on short notice for low cost, and then security is a huge factor there for cost as well. And the opportunity is that is clear. There's a lot of projects that are to develop rocket engines right now, and there's no operational supplier of these electric turbo pumps today. So we want to fill that spot, and we want to become the leader in electric turbo pumps as a supplier. And there's just one launch vehicle which is flying today, which is using electric turbo pumps, and that's Rocket Lab, and they reached orbit the first time in 2018. So it's pretty fresh, this type of technology. We established the company end of 2018, and it spun out of Copenhagen Suborbitals, as you mentioned. Yeah, and in 2019 we have basically been doing development, and I'm going to do a quick recap of what we have achieved and what we have done in a second. And we are now working towards, we are doing the first tests with water at the hydropower laboratory in Trondheim, Norway. And then we're working towards static fire test with Copenhagen Suborbitals end of this year with a 100 kilonewton rocket engine that they are developing. Yeah, and in parallel, we are now at the point where we are looking for a commercial customer to start the first project with them. So the original, as you mentioned, is from this organization called Copenhagen Suborbitals, which is, they call themselves the world's only manned amateur space program. And they have been working for 10 years towards sending the first human to space on a volunteer-built vehicle. And Orbital Machines spun out of the work that was being done on a 100 kilonewton thrust rocket engine for this vehicle. So basically, we are commercializing the pump technology, and we are also becoming then an industry sponsor by supplying Copenhagen Suborbitals with the pumps for their rocket. So here's a little update on the state of the rocket engine development in Copenhagen. I don't know.
I think we don't hear. Yeah, exactly. We don't hear the sound. So maybe if you could just say something a little bit about what we are seeing there.
So yeah, that was just Thomas Peterson from Copenhagen Suborbitals doing a very quick update on the status of the rocket engine for Spica, which is called BPM 100. And he stated that we are working towards a static fire test in August this year. That's not correct. It's been with everything that's going on, it's definitely not happening until somewhere close to the end of this year. It's a slightly old video. So a little recap of what we've been doing in 2019. We basically started the company with a crowdfunding round. We did an equity crowdfunding end of 2018, and we raised 180,000 euros on a Norwegian platform. Then in the middle 2019, we were ready to launch the product at Spaceport Norway. This is our first kind of product line, which is called the Mosquito, and it's for engines in the thrust range of 30 kilonewton to 100 kilonewton, more or less. We were at Space Tech Expo Europe, and there, for the first time, we made basically contact with a whole bunch of companies that are working on launch vehicles and rocket engines. And yeah, we have a lot of requests for this, and we are just working as hard as we can now to actually make proposals for all of those and find the right project to start on working for a commercial pilot. And then we moved from Norway to Berlin, and we are now based at Motion Lab. We have our own little lab inside of Motion Lab where we are working on this stuff. And we raised 200,000 euros in various grants, matched with another crowdfunding round on the same platform for another 200,000 euros. And we produced the first functional prototype, which will now go into testing with water. And yep, and I guess I'm finished. I was modifying this a bit in the last minute, so the ending came a bit surprising to me now. I'm open for questions. No.
Yeah, thank you very much. That was really cool, really nice to see.